participate in the Ontario mite participate in the Ontario Varroa mite counting process. I'm going to talk about that more. Remember that you want to prevent any disease spread between your hives. So what you want to do is sort your hive tools after you're using them, especially if you've got different apiaries at different locations. Inspect your hives regularly, removing several brood frames every 2 weeks, and record your observations. And consider getting a mentor or even networking with experienced beekeepers to discuss issues and trends throughout the summer season. Sorry, just 1 second here, hold on. Now, here are some observations when you're doing your inspections in your hives that you really should think about. Does the brood really look healthy? When should I add supers? Are the mite levels below thresholds, or the mite treatments required? Is there evidence that the hive may swarm? Are there some queen cells in there that shouldn't be in there? When and how to replace a failing queen? What techniques do you use to prevent a swarm? What techniques do you use to catch a swarm? How do you split a hive? What do you do if the hive has laying workers? Does it smell healthy? Remembering that American fowl brood has a very distinct odor. It smells like old socks, basically, discolored brood caps, sunken shells, stringy cells. And if you do find AFB as a disease, it must be reported to the OMAFRA and the hives destroyed. Is there any evidence of American fowl brood or chalk brood? What should be done? Is there evidence of small hive beetle or wax moth? What do you do? How do you discourage pests and such as bears and skunks? And that's where your networking really, really helps. If you can get someone either as a mentor or as a person that you can call and discuss, because there's lots of things that change all the time. Now, the Ontario Varroa Mite Monitoring Campaign 2022 is in partnership with the Ontario Animal Health Network. It really has been going for about 5 years, but this is a real campaign that they are trying to get together to have people really become aware of Varroa mites and how destructive they are. And Glenys later on is going to talk about diseases in the hive with respect to that, perhaps various wing viruses, deformed wing viruses, and so on. I'm sure she probably will talk about that. So, but this is mainly for. So what they say to do is to check your Varroa levels starting in May and during the season. Record the Varroa levels, fill in the survey on the Animal Health Network website. It's not open yet. I checked yesterday. It's still not open. Add the information at the end of the campaign, then visit that website and take a look at the Varroa map and use the information to make decisions on what and how to treat your Varroa. And just a reminder, this is a reference from the Ontario Bee Journal on October 2021. The types of the season, the methods that you would use to do your mite counts, and the thresholds. So in July, you continue to inspect those hives with all those questions I gave you earlier, and record all that information, because it's very helpful to be able to go back and see how each hive was doing, an individual recording of information on each hive. Continue to monitor those mites to ensure that they are within the required threshold. Very important. If they are or not, treat as required, following the instructions on your packages, remembering that Formic Pro or Max are the only ones you can use when you have honey supers on. Start to prepare for the honey harvest. Clean now your extracting equipment. Familiarize yourself with the OMAFRA requirements for honey containers with labels and the Government of Canada regulations for retail sales. Learn about the importance of having the correct moisture content. You don't want to have too much moisture or your honey can start to ferment. So that's very important. And considering purchasing a refractometer to check the moisture content, it is a good investment. and it can help you with your honey. Again, in August, inspect your hives and record your observations, add supers as necessary, extract your honey, but make sure that you have enough honey that you can have 70 to 90 pounds of honey, or 8 to 10 full deep supers, so that deep frames, so that there will be enough for the winter. Freeze the frames after you've extracted them for a couple of days in the freezer to kill wax moth and larvae. Monitor those mites to make sure they're within the required threshold and treat as required. Begin your winter preparation. Consider combining weak hives, considering requeening weak hives in August to have a young queen ready to go in the winter. Weigh your hives and record the weight. You need to make sure that you have adequate honey stores, or if not, supplemental sugar syrup feeding may be required. And a couple of last things here. One of the things is, please be aware about the black-legged tick. Up until last year, we did not have any black-legged ticks in our bee yard. However, they have shown up. And as late as last weekend, my son was in the bee yard and he got ticks on him, and he did extract them properly and put them into a application called eTick. You can take a picture of it, send it to them, and they will diagnose whether it's a black-legged tick, whether it's a dog tick, whether it's a deer, whatever it is, they will come back to you with that. But very important, my message here is, after you leave the bee yard, take the time to really look to see if there are anything like black-legged ticks on your insects on you, and make sure that you know how to remove them properly, because you have to you can't just pull them off. You have to be very careful taking them from the head and taking them off and plucking them off carefully, because they have little jaws that go into your skin and really send the venom in. Now, if that happens, what's going to happen in a couple days, if it is a black-legged tick, you are going to see something that looks like this. It's a bullseye, and you should be going to the doctor at that point. So my message is, make sure that you have the proper equipment on. If you're using equipment, if you're not, make sure that you do inspect afterwards, so that you don't have any ticks on you. Please be healthy and happy and safe during the summer, and we will see you in September. Thank you.
Thanks, Marion. That was very informative. A lot of information to cover over the next couple of months. And now we welcome Glenys back again from the TTP. She's going to be talking to us about honeybee viruses and Varroa mites, and how they're interconnected. Varroa mites can transmit many viruses that negatively affect honeybees. Her presentation will give an overview of the most commonly encountered honeybee viruses, their relationship to Varroa mites, and how we can prevent them. Welcome back, Glenys.
Great, thank you so much. I cannot share my screen. Host disabled, participant screen sharing.
Please stand by.
No worries. In the meantime, I will actually just talk really quickly about the Ontario Varroa monitoring campaign that Marion brought up. Thank you for plugging that, Marion. I do also work for that campaign, and we have really big things planned for this year, which is why it's taken a little bit of time to roll out. This is maybe a bit of a secret, but I'll tell you anyways. We partnered with an epidemiologist from the University of Guelph. He's getting his PhD right now, and he has worked to develop what we're calling a Varroa dashboard, which as people submit their Varroa counts, it'll show a anonymous map of where Varroa levels are high, and it's going to be very, very cool. But he just defended his PhD yesterday, so he's been very busy, so it's been very slow rolling out. But stay tuned. It is going to be very cool this year, and I can share my screen now, which is great. Oh. Can you see that? Great. Sorry, I'm all the way at the end. You'd think that I would know how to do this by now, but here we are. Okay, so we are going to be talking about honeybee viruses. And kind of the big thing to understand with honeybee viruses is their relationship with Varroa mites. So we're going to be spending a lot of time talking about that. So we'll dive right in. I know I did last month, the spiel last month, but in case anybody missed it, just very quickly, my name is Glenys Robinson, and I work for the Ontario Beekeepers Association's Technology Transfer Program. And there's sort of three main components of our work. So the first thing that we do is research, applied research for the Ontario beekeeping industry. So most of our research is focused on honeybee health, pests and diseases, that kind of thing. And we do some of our own research, and we also collaborate with different universities in Canada. Sorry, the sun is doing weird things here, but I'm a little bit in shadow, sorry about that. The second thing that we do is extension work. So we do a lot of teaching, we teach workshops, we do online presentations, we have a YouTube channel, and we talk to LBAs like you tonight, which is great. So we make sure to share the results of our research as well as best management practices with Ontario's beekeepers. And the last thing that we do is we facilitate the Ontario Resistant Honeybee Selection Program, so Ontario's collective breeding program. So we go out to, there's over 30 orbs breeders now, and we go to all of their operations and we do third-party testing for them to give them data of what stock to breed from. So that is a big component of our work as well. So getting into viruses, viruses are a really big topic, a big area of emphasis for a lot of research in honeybee health in kind of the whole world right now. It is kind of an up and coming topic and issue. So as of right now, there's still kind of a lot of gaps in our knowledge. It's still relatively poorly understood, but there is lots of new work being published and lots of new knowledge coming out. So our understanding keeps sort of growing and shifting, but there's lots of new work being published right now. So around the world, there are at least 20 different viruses that are known to affect honeybees. And there's actually, honestly, probably a lot more than that. They keep coming out with new ones. There's honestly probably closer to 30 at this point, kind of hard to keep track of. But not all of these different viruses have been detected yet in North America. So we don't necessarily have to worry about all of them here. There's kind of maybe around 10 that have been detected in North America that are more what we need to be worrying about. As well, it's important to understand that not all of these viruses are actually considered to be economically significant, which means that they may be present and they may be, infecting our colonies, but they don't actually cause damage that is deemed economically significant. So they aren't actually causing enough damage for us to worry about, essentially. So there's a lot of different ways that honeybee viruses can be transmitted. It kind of varies by virus. So not all of these ways may apply to every virus, but these are just kind of the most common ones in general. So workers can become infected when they are cleaning out infected cells. So there's often viral particles left behind in feces, or some viruses, they impact developing brood, and then that sick or dead brood has to be removed, and the viral particles get spread to workers that way. Workers can also spread it by feeding infected food to other adult bees, like you see in this picture, or to larvae. So that can be honey or pollen that has been contaminated, or it can also be their own glandular secretion. So royal jelly, which they secrete themselves, it can, the gland that creates it can become infected with viral particles, and they can pass it along that way. It can also be transmitted from shared food sources. So that means flowers that multiple bees have visited, as well as if beekeepers are doing open feeding, if they have feeders out, then bees can spread viruses between each other that way. And they can also be transmitted from the mother, so the queen, to her offspring, so from the queen to her eggs. That is called vertical transmission when it goes between different generations, and pretty much everything else that we're talking about is horizontal transmission when it's between different bees that are part of the same generation. And then a really big one that we're going to talk a lot about is that viruses can be transmitted by Varroa mites. So hang on to that thought. We are going to get to it in a little bit, but that is kind of a key to understanding the way that honeybee viruses impact our colonies. So first, I'm just going to go through some of the more common viruses that you might encounter in Canada. We'll talk about this in a minute, but common might be a bit of a relative term here. But research has shown that the most common honeybee virus, not just in Canada, but globally, is actually deformed wing virus. And that makes a lot of sense because I think it's the most common one that most beekeepers have probably encountered at one time or another. So it can kill bees at the pupal stage, but it's much more likely to cause deformity as well as early death in adult bees. So that main deformity that we're talking about is, of course, the most common symptom and where the virus gets its name, which is deformed wings. So you'll see bees with wings that look shriveled or crumpled or just not right, and that is a sure sign of deformed wing virus. Some other symptoms that you might see include discoloration. Sometimes bees with deformed wing virus, they look almost like an unhealthy, like gray or beige kind of color. And they can also be stunted and have a decreased body size, so they can be smaller. So deformed wing virus is a pretty big deal. It is pretty strongly associated with overwinter colony mortality, which we'll talk about. And it is also very, very strongly associated with Varroa mites. It has a very close relationship with Varroa mites as it is transmitted by Varroa mites. And if you're seeing deformed wing virus, that is almost always an indicator of high Varroa levels in the colony. So even if you aren't actually seeing the Varroa mites, that's to be expected because they will spend most of their time reproducing under capped brood, so they'll be hidden from you. But if you are seeing these deformed wings, that is a red flag that your Varroa levels in your colony are really, really high. Another virus that research has shown to be common in Canada is black queen cell virus. So this one, common is definitely a relative term. I've definitely never seen this one in person myself, but it has very distinctive symptoms that you can look for. It's very unique in this fact that it only affects developing queen pupae, and the symptoms will take place in the pupal stage, so they will be under the cappings, they'll be inside the cell, so it won't be super obvious, but you will see discolored queen pupae that have kind of this tough leathery skin, and then they will die in the cell as a result of the virus before they can emerge, and after death they will turn black, like the pupae themselves will turn black, and then the walls of the cell and the interior of the cell will also turn black. So yeah, pretty unique in the sense that it only affects queens. This is commonly a problem in hives that you are using for queen rearing. So if you have cell builders or if you're doing any grafting and queen rearing, and one way that you can help to prevent it that is kind of specific to this black queen cell virus is to not reuse your grafting cells. So those little plastic cups, the JZBZ little plastic cups, those are a one-use thing, don't reuse them. Another notable virus in Canada is the Israeli acute paralysis virus. It's named that because it was first identified in Israel. And this one is actually part of what we call the AKI complex. So what that is a group of 3 viruses that are very closely related to each other. So we kind of lump them in together when we talk about them. So these 3 viruses are the acute bee paralysis virus, the cashmere bee virus, and the Israeli acute paralysis virus. So you may, if you're doing more research on viruses, encounter the term AKI complex, and it's these 3 viruses that kind of, they're very closely related. They just kind of, we classify them together, if that makes sense. So the Israeli acute paralysis virus in particular, it can infect bees at all stages of development, but you will see the symptoms present in the adult stage. So you can see shivering bees, or bees that are kind of vibrating their wing muscles. You can sometimes see bees, worker bees in particular, that are dark and their thoraxes are hairless. I do want to point out that there is another very common time that we will see this symptom in particular, these hairless thoraxes, and that is when bees have been out robbing other colonies. So when they're robbing, they're all kind of mingling and fighting and getting into trouble, and they get kind of roughed up and their hairs all get kind of worn down. So if you see dark and hairless thoraxes, don't automatically assume, oh my gosh, I have this really acute paralysis virus. Another symptom of this virus is paralysis, and then it will eventually lead to death. So acute bee paralysis virus, it also causes paralysis and death. That's one of the reasons that they're closely related. And then the other one that's part of this complex, the cashmere bee virus, it doesn't actually have any visible field symptoms other than colony mortality, which is not a very helpful symptom. So yeah, that's all I want to say about that one. And then I'll end with sackbrood bee virus, which is maybe a little bit more common, something that maybe some beekeepers have seen before. It's more commonly referred to just as sackbrood, so people don't always actually know that it is a virus. But sackbrood typically affects brood at the larval stage. Usually pretty young larvae are the most susceptible to sackbrood, but adults can also become infected. So the symptoms that you'll see in developing bees at the larval stage is you'll see discolored larvae, and they will start to develop leathery skin, kind of similar to the black queen cell virus. But then under the skin, this big sac of fluid will start to accumulate, which is a little bit nasty and where it gets its name. And that fluid actually contains millions and millions of viral particles, which are, what the workers need to actually ingest in order to become infected and to pass that infection around. And then as the disease progresses, because of that leathery skin, the larvae won't actually be able to pupate properly. They won't be able to shed that skin in order to pupate, so they'll die before pupation. And after they die, they'll start to dry out and they'll become kind of shriveled. And they have this very distinctive elf shoe shape where the head kind of curves up, kind of like if you picture a pointy elf shoe, then the head is the point of the shoe. Adults, like I mentioned, they can become infected, again, usually when they are cleaning out infected brood cells. They won't show any visible symptoms in the adult stage, but they will likely have shortened lifespans and they will start to pass the virus along. So they'll be kind of agents of transmission. Now, I know I said that these were, the most common viruses in Canada, but some of these aren't actually very common in terms of beekeepers actually seeing them, and there's a reason for that. So viruses are often latent in colonies, which means that they're present, they're there, but they're present at levels where they aren't actually doing a lot of harm. They aren't actually doing damage yet. So in the case of, the research where they're looking at which viruses are the most common, these viruses would have shown up on, their genetic testing that they were doing, but they wouldn't actually be showing symptoms very likely yet. So it is possible that these viruses are present in your colonies, kind of at benign levels where they're latent and they're not actually doing any damage yet. However, when the colony becomes stressed, some of these stressors can kind of trigger more severe viral infections where you start to see the symptoms and you start to see these viruses actually causing harm to your bees. So these stressors that can potentially, have an effect on the viruses within your colonies can include pests. Noticeably, Varroa mites are incredibly stressful on a colony, as well as the other ways that they're related to viruses, which we'll talk about. Different pathogens, different diseases, especially nosema and European foul brood, they can definitely trigger more severe cases of some of these viruses. And then also environmental issues. So things like if there's a dearth, if there's no food in the environment, or pesticide exposure, anything like that that's going to be stressful for your colony. So I keep bringing up this relationship between viruses and Varroa mites. So let's actually dive into that. So Varroa mites are vectors for most of the honeybee viruses that we know about. So what that means is that they can actually spread these viruses between different organisms. So another example of a vector that's already come up tonight is ticks. Ticks are a vector for diseases like Lyme disease. In the same way, mosquitoes are a vector for diseases like malaria and Zika virus, that kind of thing. So what happens is the Varroa mites, they will transmit viruses as they feed on developing bees. So they actually puncture the bee's body and they transmit these viruses directly into the bee. And it's kind of the perfect storm because as they are transmitting these viruses, as they're feeding on these bees, they're also what they actually feed on is the bee's main immune organ. So as they're feeding, they're also weakening the developing bee's immune system. So they're transmitting viruses at the same time that they're weakening the immune system. So the bees are being exposed and their immune systems are taking a hit, so they're less likely to be able to fight it off. That makes them more susceptible to these viruses. And it's also worth noting that some viruses, in particular, things like deformed wing virus, they can actually replicate inside the mite's body. So they can actually multiply in there. So that means that the mites aren't just spreading the viruses around, they're not just transmitting them, they're actually increasing the viral load that is present in these colonies. So that is not the case with every virus, but definitely things like deformed wing virus, that is the case. And that is why deformed wing virus in particular is really closely associated with Varroa mites. So research is actually showing that most of the negative impacts that we associate with Varroa mites are caused by the viruses that the mites are spreading, not by the physical damage done by the mites themselves. So understanding these viruses is really kind of the key to understanding the damage that Varroa mites are doing to our colonies. So I put this on its own slide with a picture of a frame from a dead out to really emphasize this point, to really drive it home. But the impacts of these viruses, they persist even after Varroa mites have been controlled through chemical treatments. So that means that even if you kill all the Varroa mites in a colony with chemicals, if they've already spread these viruses to the developing bees, then that means that even if you get rid of all of the mites, the effects of those viruses will still be there. So the damage is already done, whether you get those Varroa mite levels down to 0, it doesn't matter, the damage has been done. So to really kind of dive into that idea, we'll talk about the relationship between viruses and overwinter mortality. So if you think about when the Varroa mite population peaks, when there's going to be the most Varroa mites in the colony, that is around late August. And that is a month or two later than the bee population peaks. It peaks much earlier in the spring, kind of around the end of June or early July. So that means that at this point in late August, you're going to have a whole bunch of varroa mites that are parasitizing very few bees, or not very few bees, but fewer bees. So that means that that is when you're going to be seeing the most damage from varroa mites when that mite to bee ratio is very high, when there's a lot of mites per the number of bees in a colony. And at that same time that the varroa mite population is peaking and we're getting these heavy varroa mite infestations, this is also when winter bees are being raised. So winter bees are actually physically different from summer bees, and these physical differences allow them to live longer. So this is how colonies actually survive over the winter when there's no brood rearing taking place and there's no, constant, what am I trying to say? There's no, new worker bees being added. So these winter bees can live really long if they're nice and healthy. So it's really important that you have healthy winter bees in order to allow that colony to survive until spring. But because these winter bees are being raised when the Varroa population is peaking, they are more likely to be infected with viruses, as well as to have all the other negative, kind of physical impacts as a result of Varroa parasitism. And if they're infected with viruses, then they're not going to be healthy. They're going to struggle to survive over the winter. And again, just to drive it home, even if you kill the mites, the winter bees have already been infected with these viruses. So the timing that you apply your Varroa treatments is really critical. That's why it's so important to constantly be monitoring throughout the season so that you aren't actually ever letting your mites reach these really damaging levels. So talking a bit more about virus prevention, there are no chemical treatments that work for viruses. There's no treatments that you can put on, which means that in this case, the best offense is a good defense. So the best way to prevent viruses is just to kind of make sure that you are, that you're keeping your bee populations healthy, nice and queen right and strong, and preventing stressors. So we'll dive into that in a second. So because viruses are so interrelated with Varroa mites, the number one best way to prevent viruses in your colonies is to keep Varroa mites under control throughout the season and never let them reach those super damaging levels where they're above treatment thresholds and they're causing that severe harm to your bees. And there's kind of 4 steps to go about this. So the first thing that you need to do is to be constantly monitoring throughout the season using an approved monitoring method. So the reason that's important to use an approved method is because an approved method will give you that treatment threshold that tells you when you are actually at a point that you need to treat. So it takes the guesswork out of it. Some people, they monitor visually and they wait to see signs like mites on the backs of bees or deformed wings from deformed wing virus. But that is not great, because by the time that you're seeing those things, that means that the infestation is already really high and that damage has already been done. So ideally you want to stop things from getting out of control before you're starting to see these signs of severe infestation. Another thing that you can do is use cultural controls throughout the season to control Varroa population growth. So that includes things like drone brood removal. You can buy kind of those green plastic drone frames that you can basically use to trap Varroa mites in your colonies and then remove them. So the way that it works is that Varroa mites are actually more attracted to drone brood. So they go to these drone brood frames, you leave them in until all the drone brood is capped over, and then you remove that frame and you remove all that brood, which means that you are removing the Varroa mites. So doing these things isn't going to actually control the Varroa mites. like a chemical treatment, and it doesn't replace the need for chemical treatments. But what it does is it slows the growth of the Varroa mite population. So it kind of buys you more time before they reach these really damaging levels. Another example of a cultural control is incorporating genetic stock that is resistant to Varroa mites. So that is something that is being incorporated more and more in the ORBS program. There's a few different kind of genetic traits that you can breed for that again slow that Varroa population growth down. So these things again don't replace the need for chemical treatments, but they do buy you more time and maybe mean that you can stay away from heavier synthetic treatments that are more likely for the Varroa mites to develop resistance to. The third thing is to use chemical controls when indicated by monitoring. So monitoring, again, is really, really critical because it'll tell you exactly when it's actually necessary. You don't want to be applying chemicals when it's not necessary because that's, a waste of your time and money. But more importantly, it can lead to Varroa mites developing resistance to chemicals. And it can be really hard on your bees, especially if you're putting like multiple treatments on that aren't necessary. So we want to be using chemicals, but only when it gets to the point where it is actually necessary as indicated by our monitoring. And like I've been saying over and over throughout this presentation, don't wait until it's too late to treat. Again, even if you kill those Varroa mites, if they've already passed on those viruses, then the damage is kind of already done. So you want to kill the Varroa mites before you reach that point. Kind of one of the main ways that this comes up is people always want to try and catch that last fall honey flow. They push their treatments off a little bit just so they can get that last bit of goldenrod honey, and that is definitely not worthwhile. You will not make enough money from that honey to make up for the loss of those colonies if you let those Varroa mite populations get out of control. So always prioritize the health of your colonies if you're in that situation. Never hold off treating because you want honey or for any reason like that. We can't get into all of the absolute nitty-gritty of Varroa control today, but we do have a series of Varroa mite lectures that is on the Ontario Beekeepers Association YouTube that really gets into like the very fine details of Varroa mite biology and population dynamics and treatments and controls, and also genetic traits that confer resistance. So if you want to learn more about controlling Varroa mites, I would really recommend that you give those a watch. There are 4 videos on our YouTube, which is the Ontario Beekeepers Association on YouTube. And then, like I already mentioned, some of these viruses can kind of be activated to damaging levels in the presence of other stressors. So it's really important that we use best management practices to keep our colonies strong and queen right and healthy. So other issues, other stressors, in particular other pathogens, they can really stress out colonies and they can exacerbate these viral infections. So some viruses in particular have been found to be kind of triggered or activated to damaging levels in the presence of pathogens like European foul brood and nosema. And that's kind of interesting because European foul brood and nosema, they are both stress-related issues in and of themselves. So both of these are things that you won't necessarily be seeing if you are keeping your bees strong, queen right, so that they never end up with a dwindling population because they didn't have a queen to lay fresh eggs and bring that worker population back up. Sorry, I lost my train of thought for a second there. Stress-related issues that you can kind of prevent just by keeping your colonies strong and healthy and well-fed. If there's a dearth, that can be a big component to both of these diseases. Just trying to do everything that you can to limit these stressors just by following best management practices. So it's not necessarily a game of dealing with an issue after it's already happened. It's more proactive. It's about trying to prevent these issues before they get started. And one last very tangible thing that you can do to control viruses as well as other issues within your hives is to cull old brood frames. So there's a whole lot of reasons that we recommend getting rid of old brood frames. Sometimes we hear from older beekeepers who are kind of bragging about having had the same frames in their operations for 20 years. And that is not something to brag about. That is not ideal. That is not what we want. So old comb can harbor spores of different diseases like American foul brood, European foul brood, chalk brood, and nosema. And research is showing that it can actually also harbor viruses. So new research by Megan Colwell, who is a PhD student at the University of Manitoba in Dr. Steve Purnell's lab, her research has shown that some viruses are able to actually persist in beeswax, which means that they can likely be transmitted to the bees through the wax. So the actual, the details of which viruses are being transmitted, as well as the extent to which they're transmitted, how long they need to be there, all that kind of thing, all those details are still being researched. She hasn't kind of gotten to the bottom of all those things yet, but she's definitely showing that keeping old beeswax around is not the best idea. So that's really interesting. That's actually really unexpected for viruses. They typically don't survive on surfaces for very long. So I'm really interested to see where this research goes and to see the rest of the results of her research. But something new to be aware of is it actually can linger on beeswax. As well, old brood frames, they can sometimes contain chemical residues. So they can contain residues from past treatments that have been applied, which is one of the reasons that we really recommend that you never eat honey that's from your brood chamber. You only want to be eating honey out of the supers, as well as the potential to hold on to, pesticides from the environment that have maybe been brought back in pollen, things like that. So overall, beeswax, it just really likes to hold on to things, onto disease spores and chemicals and potentially viral particles and all kinds of bad stuff that we don't want in our hives. So it's really good to limit the amount of years that we keep these brood frames around for. So we recommend that you replace 1 to 2 old brood frames in every hive every year. It's kind of easiest to do this in the spring when there isn't a ton of brood production happening. Another thing that you can do is you can label all of your frames with the year that they went in, and that'll give you a reminder of how old they're getting and which ones need to be replaced. So you can just write on them in Sharpie and it'll give you that visual reminder. Sometimes people don't like the idea of constantly replacing their frames because frames can be a little expensive, but it really is a good investment in terms of keeping your bees healthy. So definitely getting rid of those old brood frames will do you a world of good. All right, I'm not sure how much time that actually was, but that is all I had to say today, but I'm definitely happy to take questions if there are any questions.
It looks like there's some in the chat.
Oh, yeah, for sure. How do I see? 1 second. There we go. Have you personally seen Israeli paralysis virus? No, I haven't. It would be really interesting because some of those symptoms, like the kind of the shivering and even the paralysis to a certain extent, that can be seen with like acute pesticide exposure sometimes. So it'd be really interesting to see the difference there. But like I said, common is kind of a relative term when it comes to viruses. So research has found that it is one of the more common ones in Canada, but that probably means that it is more likely to be latent in your colonies rather than you're actually seeing the symptoms. Is there a time where you are more likely to see these viruses? It kind of depends on the virus. So for example, deformed wing virus, you are more likely to see in late summer, early fall, after those Varroa populations have peaked, because they are so strongly associated with the Varroa levels in your colony. Other than that, I don't have any firm examples. Maybe if you don't mind, I will think about that and get back to you and send you an email that you can pass along to the group. I guess maybe a more general answer to that question would be, you might be more likely to see them in the spring when you're seeing other stressors are more common. So other stress-related diseases like European foul brood and nosema, they are more common in the spring, which probably means that viruses might be more likely to be seen in the spring because they're stress related as well. And spring is a very stressful time for bees. So spring if it's stressful, fall if there's a lot of Varroa mites, I would say. Do you think that it is possible to reach a point in the future where most honeybees are resistant to Varroa mites? Will it make them more susceptible to the viruses that Varroa mites carry if they can tolerate the mites? It's kind of a loaded question. Like down the road, like very far down the road, I think it might be possible. We've had a lot of success in breeding for tracheal mite resistance. And it's complicated because Varroa mites, they were originally from a different species of honeybees, like eastern honeybees, Apis ceranae. And Apis ceranae, because they evolved with Varroa mites for thousands and thousands of years, they are really resistant to Varroa mites. But because they're a new pest in European honey mites, it's more difficult. But there are definitely genetic traits that make them more resistant, but it'll definitely take a lot of time, a lot of effort, a lot of very intense selective breeding to kind of get there. It's kind of a hope and a dream for the industry very far in the future, but we are unfortunately pretty far from that yet. But that doesn't mean that you shouldn't go out and try and source some bees that are more resistant to Varroa mites. Again, that's something that is being incorporated in the ORBS program, and it will help you out in terms of, again, slowing that Varroa mite population growth. But as of right now, again, it's not enough to mean that we don't need to use chemical treatments even when they have been bred for resistance traits. The second part of that question, will it make them more susceptible to the viruses? I actually feel like it would make them more resistant to the viruses. I feel like that, yeah, like if they're going to be resistant to the Varroa mites, then I don't know. I feel like there would have to be a viral component, but I'm not a virologist. I don't know. I don't think that there's any reason that it would make them more susceptible to the viruses, though.
Are there any more questions? You can unmute yourself if you'd like to ask Glenys directly. No, okay. Thank you very much for coming again. We really appreciate it, and we appreciate all the information that you're giving to us. It's certainly timely, so that we can look for these things while we're in the hives this summer and going into the fall. So thank you, thank you, thank you.
Yeah, of course. Thanks for bearing with me. I feel like words were a bit of a challenge tonight. So thank you for your patience.
I think you've had a very long period of craziness. So we appreciate you coming in here and doing this for us. And we'll try our best to kind of grab you when it's not so crazy busy.
Yeah, for sure. Thanks so much, guys.
Okay, I think we're going to just jump into sort of the last part of our meeting today, and that is just having a casual chat about maybe what's going on in your bee yard, or if you have any questions that maybe some of the more experienced beekeepers can answer for you, and certainly Glenys if you're available. So just jump in there. You can either pop them in the chat or please unmute yourself and we can start chatting with each other. Okay, here's a question for you. How are your hives doing? Does anyone want to tackle that? Okay, I'll go first. I lost a lot of my hives. I believe it was partially because I was very busy in the fall. I usually leave a medium super of honey on my hives, just to sort of double check that. And where we were, I don't know if it was everywhere else, the temperatures were up and down like the Dickens, and I knew that I needed to feed and I just didn't get there in time. And so the hives that I lost looked like they starved out. Everything was just gone. But thankfully I have one hive left, and I'd given a hive to somebody else, and both of them, well, her hive is doing really well. My hive is taking some time to kind of ramp up right now. Our temperatures here, I'm just outside of Kingston, and they've been a little different than the ones in Toronto. They've been a little cooler. So yeah, so I'm desperate to get in tomorrow. Hopefully it'll be a sunny day and I can kind of see what's going on and hopefully make some splits. So that's what's going on with me. How about anybody else?
Are you going to do walkaway splits? Or are you going to get mated queens?
Walkaways. Yeah, I think the last time I went in last week, and that was the first time I saw drones really. So they've just taken a long time to start here. I'm not sure what's going on.
So I'll tell you a little thing I did by accident, kind of, and the result this spring, because you talked about drones. I had a colony that was that was in a medium super, and they were I'm trying to get everybody into deeps, but some of my colonies had a deep and a medium, and the colony was so small that it was only occupying the medium. So I pulled away the deep because I didn't want to give it too much room, and I stuck an empty frame of a honey frame that had just recently been extracted on top, and this was maybe August. And so the colony did really well, and and so it overwintered as two mediums, and that's fine and everything. But I wasn't super careful at looking at the frames when I put them in. And what I noticed was that there were 3 frames of cut comb in the colony in there. And what ended up happening was the cut comb frames were drawn out by the bees. And so the cells were significantly larger than the frames that had foundation on them. And you want to talk about drone overload. I opened up this box and I took a look inside and I thought, oh my God, I must have a drone layer, because it looks like 50% of the bees are drones. But then as I was doing my inspection, I found 3 cut comb frames that were like, well, they were IPM. They were like drone traps, and they were full of drone comb. So I actually was able to pull them out and throw them in the freezer, and whatever. If somebody had chickens, I would have given it to them. But anyway, so just a reminder that if you accidentally leave cut comb frames in and then they start laying brood in it, you are essentially putting in those drone sacrificial frames, that we pull, and that to not be surprised when your colony is like packed full of drones. So it did take some investigation, because I was really worried when I first started going into it, but then I saw the cut comb and I'm like, yeah, that's what happens. And normally I don't extract my cut comb. Oh, also note to self, normally I don't extract my cut comb. Normally I, I cut it out and sell it. But for whatever reason this year, I just couldn't be bothered. I was too lazy. And that's how the cut comb frames ended up back in there. Laziness happens a lot with me.
It's interesting. Would anybody else like to tell us what's going on in your bee yard?
Yeah, I just got a nuke last week and installed them, so I'm excited. And they were very calm. They're the calmest nuke I've bought, so that was kind of nice. Made it easy. And but I lost my bees last winter, and I think they absconded pretty early. I wrapped them in one of the black wraps too early. There were some hot days in November, and I think they just got too hot maybe. Because there was lots of honey left and not many dead bees in there. So anyway, for whatever reason, they took off. But I'm glad to have a new nuke.
If I could jump in there for a second, what you're saying you know, lots of honey left behind, all the bees left, no dead bees in late fall, that is a classic symptom of a Varroa death.
Oh,
Yeah, so it could have been for another reason, but whenever I hear that, I always recommend that people take a look at you know, what was going on with their Varroa levels and what treatments they put on and that kind of thing, because that is a classic Varroa mite symptom.
yeah, I did treat. I didn't measure afterwards, so I'm not sure how effective it was. But do you think the black wraps put on too early could like just overheat them? Is that also possible?
I guess it's technically possible, but bees are really good at cooling things down. It's much easier for them to cool things down than it is for them to heat them back up. So I think you'd be more likely to see them all outside bearding and fanning and that kind of thing. I guess it's technically possible, but I wouldn't say it's the most likely scenario for sure.
Yeah, I'm not there enough to really know what's going on. But yeah.
Why would there be no bees left, Glenys?
So in some cases, when Varroa mite infestations are really high, they do actually abscond. Like they're just like, we are too sick. There's too much going on. We're just going to leave, and they all abscond, and then the colony is empty. And in some cases, when you aren't seeing, sorry, what words am I trying to say right now? In some cases, it's more a case of the population just kind of dwindled away. Sometimes when they do get sick, they will, like individual bees will just kind of leave the colony and go off and die, so that they are kind of like removing themselves as a source of infection from the hive. So you can kind of see both of these scenarios play out. And in some cases, it's just that like they were so sick that they couldn't even raise new brood because the Varroa infestations were so severe. So the population kind of dwindles without being replaced because the brood is so unhealthy. So yeah, like you'll kind of just end up seeing empty hives, often with a lot of food left, and you're like, oh my gosh, like they had so much food, why did they leave? And yes.
So I'm just in my second year of beekeeping, and last year our big goal was to keep the bees alive, and I'm happy to report that they made it through the winter, so that was good. In May, it looked like they were just about to swarm, so we did a split, and just yesterday or the day before, after the waiting period, I went in and I've got a queen laying in both of the two hives, so I'm feeling cautiously optimistic. And also feel like the learning curve is so steep. Every time I go, I make mistakes that I learn from, but pretty excited to be here, so, and happy that the bees are so far doing good this year.
That's great.
I lost 3 out of my 6 hives. And it was like piles of dead bees covered in mold. So I feel like maybe they died early on. I wrapped them, I fed them early. I did a mite count before and it seemed okay, and I tested them, but yeah. And now the weak hive that was only one super overwintering is the strongest hive. And yeah, the other 2 are doing fine. So
That's good. I feel like there's always hope when you've at least got one left there, right? So
Are you going to be splitting your hives, Renee?
yeah, I'm gonna see about maybe doing that this weekend, like checking in on them. I also tried the what is it, Apivar Life?
Yeah,
I tried that treatment in the spring, so I have to go do a mite count now. And just see how it went. But it was really crumbly to work with, Eileen was so good at like, don't crush the packages. So what did I do? Crush the packages. So
is that a time-based
I think so.
Yeah,
it's
so
like it's organic. It's this new organic treatment that you can put on. So
but it has a treatment period. It's pretty long, and then it has 2 weeks that you have to leave your supers off after.
My understanding is what I did was I put it on, I treated for first week, I put it on, then came back, did a second treatment for another week, and then a third treatment for the following week.
All right.
So it is a bit like you got to be there, but supposedly it doesn't affect your honey. You can harvest whenever, and there's no, time limit. So time limit, get it? Haha, time.
Hi. I overwintered 4 hives, and I was happy that they all made it. I thought one had for sure kind of died, and it's actually my strongest hive now. I split all 4 of them 2 of them I split about a month ago, and the other 2 I split about 3 weeks ago. So I did check them all the other day. 2 of the splits, I did walkaway splits, and 2 of them have laying queens, and they look to be doing really well. The other 2, the one I couldn't find any eggs, and that was one that I did 3 weeks ago. So sorry, my dogs are all playing. I don't know if it's like, if there's still any hope that maybe she just hasn't started laying. If I'm going to check again in a couple days, and I'm going to put a frame with some eggs and brood in if there's no queen at that point. And then the other one that I did, I opened it, and there was tons of drone brood. So I'm kind of stumped right now because I couldn't find any eggs, and I'm fairly new, so I don't know if I had a drone layer. I'm thinking I would also see eggs, but there must be something laying to have made the drone brood. So if anyone
How long
has
ago did you have a queen?
So I did the split 3 weeks ago.
So there's still cat brood in the colony?
There's capped drone brood only. There's no like regular brood.
When you did the split, was there open brood?
There was open brood and cap brood.
So the open brood would just be like emerging now, right?
So there's, all the brood has emerged except for these like capped drone brood. So could that be left over from?
I mean, this is prime drone production time, and the drone brood needs 24 days, and the cap brood only needs 21 days. And there was a queen in there 3 weeks ago. So I don't think I'd be jumping to any conclusions yet.
Okay.
And it was 3 weeks ago that you did your split?
For those 2, yeah. And I do see the queen cells, like they've like chewed themselves out, but I couldn't find any queens.
And what's the temperament to your bees?
They're fairly gentle. Like they're pretty, like I don't really wear a suit often. Like I sometimes wear gloves.
So they're not acting agitated, they're not acting queenless.
Okay. So if I check again,
I think you just need to have more patience. That's always the hard part when you do splits, man. You just want to see that queen, and you want to see the eggs.
Yeah.
You keep going in there, and every time you don't see it, you think, oh, I don't have a queen. And then you give it another week or, whatever. And yes, I wouldn't be panicking yet.
Okay. So just check back in a week or so.
Mm-hmm. Glenys,
Awesome.
Any comments?
No, I feel like Michelle is kind of right on the money. Like, it seems pretty strange if this was only 3 weeks ago for there to only be drones. That doesn't make a whole lot of sense, especially if it's capped. You're welcome to, next time you go, take some pictures and send them to the tech transfer email. It's always kind of a little bit easier when we see pictures to know exactly what's going on. But yeah, I think it sounds like they're still doing okay for queens. You said you weren't seeing eggs, but there's no open brood that you were seeing?
No, not that I was seeing, no.
Okay, that's like a bit strange, but yeah, I'd see what's going on next time that you go back, and if it's still not looking good, then definitely you can send us some pictures. I'll put our email in the chat here.
Thank you. Thank you.
Sorry. Is there anybody else who'd like to tell us about their yard?
Glenys, I want to get your opinion on something. I was going to say, if you go into your colony and you find that they're starting some queen cells, the easiest way to give yourself some insurance is to pull the queen and make a split with her. And then that way the colony will requeen, and then you got 2 colonies. And if it doesn't work out, you can recombine them. And last year when I did that, the split swarmed anyways. So the colony requeened and it was fine, but the split actually, it swarmed and it left behind capped brood, which wasn't the end of the world, because then I just took the capped brood and I put it back in the colony and whatever. But someone said it's because I gave them too much brood and I didn't simulate the swarm well enough, and I should have given them a much smaller amount of brood in the swarm simulation, so that they wouldn't still think that they needed to swarm.
I wouldn't agree with that. It's not so, like, swarming is triggered by kind of a variety of factors, and it's not so much about the amount of brood that's present. It's about whether the queen has space to lay, but more importantly, how populated the colony is in terms of adult bees. So it's the queen's pheromone that is kind of preventing swarming. And once the colony gets really, really populated with bees, they can't spread that pheromone out as well. So like all the, the peripheral bees are like, oh, I'm not getting any pheromone here. Like, what's going on? We're too crowded. It's time to swarm. So I wouldn't say that brood should be a huge factor there. When you say that the split swarmed, how long after you made the split was that?
Within a week.
Oh, that's
yeah. So I put the split in I pulled, I just did a typical one. I gave them 2 frames of brood. One was open, one was capped. Then I gave them an empty frame and I gave them, some honey and pollen. And then I came back less than a week later and they had left the brood behind. So.
And there are just no bees left.
Yeah, there were like 30 bees.
Oh, that's really
like the ones that were out when they swarmed.
That's pretty strange. It almost sounds more like they tried to go back to their original colony, maybe.
Oh, how interesting. I never thought of that.
Yeah, because like sometimes she can like, especially if like it was in the same yard, she can be like,
absolutely in the same yard. But I mean, there were, the other colony had 5 or 6 capped queen cells when I actually did the split. So,
I almost wonder if they tried to go back, whether the queen made it back or not. Like if she made it back, then if there was a new queen, they probably just killed her, or she could potentially have just not even made it back, but the bees wandered away because there's no queen.
I guess that's always a risk, I guess, then. That's just like I've never had it happen before, so.
Yeah, no, that sounds pretty strange. I might ask my team about that and get back to you maybe, because that's a pretty weird scenario for sure.
Okay, I've got a question for everybody. How big are you wanting your yards to get, or how big do you think is a manageable size, or depending on what you want to do with your honey and your bees? I know for myself, I think I was at 6 to 8 last year, and that was a lot for me. My husband has given up the ghost because he got stung a few times and did not enjoy it, even through the suit. And so I'm on my own, but I'm thinking that that's too much for me. So I think I'm aiming to stick around 4 hives. But we went through a lot of honey last year. I've kind of been substituting and using honey for everything I was using sugar for. So I was actually surprised at how much honey we've gone through this last year, but I was just wondering about everybody else.
Yeah, I definitely have that issue of when is your hobby not fun anymore? So I think I had after I did my splits last year, I had about 9 hives at the cottage. I had 3 in Coldwater and I had 2 in Toronto, and I was absolutely at my limit. It was just a lot of running around and inventory on what apiary had what equipment and where I had to carry stuff back and forth, and it was a really big pain in the neck. So I now am limiting myself to 6 hives per apiary because it just makes it easier to control the equipment. And then in Toronto, I actually just want 2 because I have a very small front yard. But yeah, I agree. And I think it's when you start to feel like you're being run off your feet by your bees because you have other commitments, then that's when you're done. Like that for me, that's when I was done. So I definitely am cutting back.
Glenys, do you have like different equipment that you guys use for lifting and doing things that sort of eases that part of it?
Not really. Like we have, a decent size, well, not decent sized team, but we're never out in the yard alone. So if things are really heavy, then we always lift them together, which is not very helpful when you are working alone. But you can definitely make yourself or buy a little stand and have it to a height that works for you. And then instead of having to lift things like all the way down and all the way back up, you have a stand that's kind of at mid-level. So you don't have to like go all the way. Like you can put it down on the stand and then take it to wherever you go. So it's kind of taking like, the intensity out of the lifting. You can also, I don't know, for your honey harvest, like rent a dolly or something that can make things a little bit easier for just like moving boxes around. Beyond that, I don't I don't have any fancy suggestions, unfortunately.
Actually, I found at Canadian Tire last year, I found a bricklayer's kind of wheelbarrow or cart, and that was awesome for taking like the honey harvest frames out. And maybe I could even use it to put the boxes on because it's a little bit higher. That's interesting. Yeah, that's a really good suggestion.
I know Paul Kelly at the University Research Center also has plans for some kind of either a wheelbarrow or a modified wheelbarrow that's like specifically for honey boxes. So that could be something to look into as well. I can't really remember the details of what it's like, but something out there.
Mm-hmm. Are we all just sort of hobby beekeepers, or is anybody wanting to grow their yard into something that they can kind of go commercial with?
I'm just a hobby beekeeper, and I like you, Lucy. My husband does not love getting stung, so he'll help if like I absolutely need it. But he also does like welt up pretty good, so it's not his favorite thing to do. So I had it in my head that 6 was going to be my max. Also more so because I don't want like where I am, we have a lot of land behind us, but we do have neighbors on either side and like around, so I didn't want too many and then having people start to complain about bees everywhere. So I do have 8 now, and my hope had been 6, so I don't know what that says about me, but yeah, definitely if I get many more, I'll have to find a second location.
Do that. It's addictive because when you know that you can split and you are getting more, it's kind of hard not to want to do it,
Yeah.
You guys are scaring me. I just have my 2 little hives and they're on my roof. So I'm thinking I don't want too many. And I started with my son, who was 21 at the time, and he's since moved. So like you guys, I'm kind of like mostly on my own, except when he comes to visit and then he helps out a bit.
Nicole, the issue happens is that you'll have a hive and you'll open it up and you'll find it has 20 queen cells in it. And so you need to manage it. And well, you don't have to, but I mean, in the city you do. And so the temptation, of course, is to take 2 frames and like make like 4 splits out of it, because you can. I think that's what
Yes.
happens is you don't want to just cut down all those queen cells. You get in there and you go, oh, if I use 2, then I could make 4 splits from this. And that's kind of how it happens.
I can see it in my future. I'm a little bit worried, yes.
But you always a reminder that you can recombine in the fall. And this is
Yeah.
something that, so I'm on my, I think I'm only on my 5th year of beekeeping by myself. I beekeeped with another beekeeper for 2 years. I had a mentor, Fred Davis. And one of the things he would always say to me that never really hit home was to always run strong colonies. And I think that I was just like, oh, I'm sure I could just help them if I did this, if I did that, if I did that. And now what I've realized is it's actually a very poor strategy to help anything that's limping along. I'm not talking about colonies starting out in the spring. I'm talking about, now it's the beginning of August, you go in there, you're taking a look, and you've got a couple of colonies that aren't doing great. And I'm ruthless now with them. And if somebody isn't doing well, it's probably for a good reason. And I absolutely will combine and pull the queens on poor performing colonies. I mean, disease aside, as long as they're low Varroa. And it has made the world of difference to overwintering. So, and also strong colonies are better for managing pests and diseases and stresses. So that's been my new rule now is, kind of the mid-August, I take a look, and whoever's not doing well, yeah, they're toast and they get combined. And then by October, I can usually, cut the boxes down to what I want to overwinter with.
Yeah, I'll remember that advice.
I think that's a good strategy to have. Yeah.
How do you decide which, do you just go by whichever queen is oldest is the one you would get rid of, or how do you?
Well, no, not necessarily the oldest queen, the best performing, right? So I'm looking at brood pattern. There are reasons why a colony doesn't do well. I mean, it could be a dearth. It could be virus, that kind of stuff. So usually the colony that isn't doing well is the one where I pull the queen. I wouldn't be pulling the queen in a good colony because there's evidence to support her. Yeah. And I also keep really detailed notes. When I do my hive inspections, I do my Varroa monitoring every month. So every month the hive has a note on it. And so I usually know how old the queen is, if it's swarmed, what's happened to it, all that kind of stuff. So it's usually pretty easy for me to decide which queen to keep. It is very difficult though for me to kill the queen, but
Do you just smush her with the hive tool?
No, I put her in alcohol. I'm hoping to make, perfume. No, they said that you can make your own queen lure by keeping your queen. So I just have a little jar of alcohol and I just plunk my queen in it. I haven't used it yet. I'm not sure if it's real or just like a folk legend that you can make, lures from it, but that's just what I do.
On that note, I have a question for everyone. I generally don't replace my queens. I'll just, unless there was a reason, but I have heard other people who say they do replace queens every year, every other year. Do people do that here, or what are people's thoughts, I guess, on stuff like that?
Because I pull splits as part of my IPM, my queens get replaced kind of automatically. So, yeah, so it's not an issue for me, because my queens are constantly getting and then I find that once a queen is 3 or 4 years old, usually she gets superseded anyways by the colony. So I actually have never had to replace a queen.
I'm of the same sort of thinking as well. And it's a little bit more difficult for me to get a queen. And so I would rather try and do it myself or just let it kind of happen naturally.
I will say that if you hear talk of people replacing the queen every year, every 2 years, that's usually more of kind of a commercial strategy. Big commercial operations will do that because it's cheaper than spending the labor of actually looking at what needs a new queen and what doesn't. It's just cheaper for them. So that's definitely not something that I think that you necessarily need to do as a small scale beekeeper. I would, however, recommend that instead of just letting them supersede or that kind of thing, I would recommend that you buy a new queen and put her in, just so that you can stay in control of the genetics and make sure that the colony stays gentle and healthy and all of that kind of stuff. We always recommend buying high quality queens rather than letting them do their own thing.
I was curious, Mel, why did you say that you're the worst beekeeper? Let me tell you, I make some pretty phenomenal mistakes. What did you mean by that?
Oops, can you hear me?
There you are. Yeah.
You see me? Every year I seem to have a big tragedy of some sort with bees. Last year I did get a bee buddy, and between the two of us, managed to put our heads together and solve our common problems. And I got through winter, winterized 4. I made it through with 2, and I've done a number of splits, and I now have 6 single strong colonies. I requeened 2 of the splits with someone locally here. I'm in Quinte at the moment, and they all seem to be doing well. I requeened about a week and a half ago, so I haven't really checked them other than pop the lid and look in to see if there's still a bunch of bees there. So I'm very hopeful that this year, if I continue to just diligently treat properly and monitor, I'll have better success. But I'm a hard learner.
I think, Mel, that most of us have made some pretty spectacular mistakes. I know, like, it's just we don't, that's not what we share on Facebook, right? Like, we don't, that's, but we've all done it. Like, we've all,
Yeah, I'm just, I just feel I'm still a novice despite being in it for 4 years, and it'll click eventually and I'll be more confident, but for now, no.
I have to tell you though, Mel, keeping bees with other beekeepers has been the biggest learning curve for me. There's 3 or 4 beekeepers who live within like a kilometer or 2 of me. So absolutely having a beekeeping buddy is been amazing. First of all, it's way easier to lift the boxes. It's 2 sets of eyes to find the queen. It's just like, it's somebody who's constantly, oh, why did you do that? Or how about we do it this way? And it's really made a world of difference for me in my bees, because I only, you only look at it from your own set of resources and experiences and training. And when another beekeeper comes in there, all of a sudden everything's different. And, it's really great. And I really, really encourage beekeeping buddies. I think it's a really good idea.
Yeah, and especially making mead and stuff all winter, it was really handy to lift those big carboys. Okay.
Does anybody else have any other questions or comments? Okay, I think we're going to wrap up a bit early this evening. We are really looking forward to meeting in person again in September. Fingers crossed, we'll let you know hopefully a couple of weeks before our September meeting if everything is still a go, and we hope to see you all there. So thanks for coming tonight, and thanks for all your comments and your questions. And thank you, Glenys, for loading us up with a lot of information again. We really appreciate it. Okay, good night, everyone.